Okay, in this podcast, we're going to look at Lewis structures, which is essentially taking those dot diagrams we just learned and drawing them for molecules.
And this really helps us explain why certain molecules are made with the dot diagrams. What exactly is a Lewis structure? It's a representation of the molecules showing how the valence electrons are arranged and how they're connected to each other and why.
Covalent compounds share valence electrons. This is just a little side note. And
so these are all covalent.
Ionic compounds. Ionic compounds transfer their electrons. We don't really look at ionic compounds very much when we talk about Lewis structures. We're really just going to be concerned with the covalent. But it does come into play in the next slide we have to look at. The octet rule.
Ooh, that's the rule of 8. To be stable, atoms will gain or lose electrons to have a full outer shell.
That's the S&P orbitals, remember?
This means that they want 8, 2 from the S and 6 from the P. And this is kind of tricky. Hydrogen and helium, if you look at them, they don't have any P's.
Yeah, so they can only have 2 valence electrons to satisfy their outermost shell, essentially. So they're happy with just 2.
It's called the duet rule, technically, because they only want 2, and they'll be paired up. They won't be apart. They'll be paired up because they want to be together.
All right, step 1 in the 3-step process for writing out your Lewis structures is to obtain the sum of the valence electrons from all of the atoms.
Take each individual piece, find the number of valence electrons, add them up. And then you're going to use one pair of electrons to form a bond between each pair of atoms.
Oftentimes you're going to see lines in between the atoms. That just means that there is a pair there, so a line represents a pair because a line is
really just made up of 2 points or 2 dots, and we say each dot is an electron. So 2 dots make a line. And then you're going to arrange all the remaining electrons to satisfy the octet rule. So you want all of them to have 8, except for hydrogen and helium, they want 2.
It's okay for this process to take a little bit of guess and check. That's normal.
So let's look at water. Water's a pretty straightforward example. Obtain the sum of the valence electrons from all of the atoms.
Okay, so hydrogen has 1 valence electron and oxygen has 6.
And there's 2 hydrogens, so 1 from each hydrogen, H2O, and 6 from the oxygen. You get a total of 8. All right. Use one pair of electrons to form a bond between each pair of atoms. And then we're going to arrange the remaining ones to satisfy the octet rule. So let's take a look at how we can draw this and rearrange them.
One thing to take note of is that there are 2 hydrogens and 1 oxygen. Whenever you have a single element, usually that element is going to go in the middle of the others that are there.
Okay, so that's going to help in the guess and check to figure out how to connect them. Yeah. So there's my oxygen, and I'm going to use a pair to form a bond between each atom. Remember, a bond is a line, so I'm going to put a bond between this oxygen and hydrogen, and there's 2 dots there. So don't forget that bond is 2 electrons.
Okay, so we've taken care of 2 of our electrons right now.
And then I'll put a bond on the other side to get the other hydrogens.
Okay, that takes care of 4 of our electrons.
Okay, 4 electrons were used in the bonds. Okay, we've got 4 left because there's 8 total. So we've got 4 more to satisfy the octet rule. So let's check the atoms, see what needs electrons left.
If we look at the hydrogens, remember those are the duet rule. They only need 2 electrons.
Okay, so that hydrogen has 2. Since it's sharing both of these,
yes.
This one goes with the hydrogen and the oxygen.
The hydrogen is satisfied.
This one is also happy. It has 2 electrons. Oxygen, though, wants 8, and it only has 4. So it is not happy yet.
From what it looks like, there's still 2 remaining sides for that oxygen.
It is not happy. So this is step 2. We'll use the bonds and look for the octet rule. Step 3, let's arrange them then. There's my hydrogens. And if I notice, oxygen has 2 sides that don't have anything on it.
And we just so happen to have 2 pairs, or 4 electrons left.
So there are 8 total. That's how many we started with. And oxygen now has 8. It's happy. Hydrogens each have 2. They're good. And this is your Lewis structure for water. Okay? Let's try a few more. See if you can get these on your own. If you need to, you can write out the individual dot diagrams and see. That might help you figure out which ones go in the middle and how they connect also.
CO2 may be tricky, so just don't get too frustrated.
PCl3.
Phosphorus has 5 electrons, 5 valence electrons.
Okay. Chlorine has 7,
7.
but there are 3 of them. So 5 plus 7 times 3 equals 26 electrons.
We got 26 total valence electrons to place around this molecule. Remember, when there's one element and multiple of another, that one element usually goes in the middle, and we have to make one bond between each pair of atoms. So between each chlorine, phosphorus, there has to be a bond, at least one.
Okay. And then check the octet rule. And we're trying to fill up the octet rule, so just start filling it and see if it works at the end. 26 total.
There's 2.
Here's 2 on this chlorine, so it needs 6 more. That octet is filled.
Mm-hmm.
This chlorine is similar, as is the other one, so we're just filling up the octet rule to see if it works.
And from what it looks like about phosphorus is phosphorus has 2, 4, 6 around it right now.
Needs 2 more.
2 more makes 8. To check the work that we've done to make sure that we have accounted for all 26 valence electrons, we already know they satisfy the octet. We made sure that happened. So to check that it adds up to 26, we're just going to count each pair. So we top of that chlorine right there, we've got 2.
2 here,
4,
6, and then
8.
we're going to count these 2 right now. So they've already been counted. So there's 8.
Then go down to that chlorine, there's 2 more, so that's 10.
10, 12, 14, 15, 16. The other chlorine,
18, 20, 22,
and then we'll count these,
23,
24. And the last 2 left are up here at the top, and that gives you 26, which matches
Yep, that number
how many we
trying
had.
to find.
So this is the structure for
Octet satisfied.
PCl5.
All of our valence electrons are accounted for. We have succeeded.
We are a go. Carbon dioxide, a little trickier, probably gave you a little bit of trouble. Carbon has 4 valence electrons, oxygen has 6, and there are 2 of them. Okay?
That's a total of 16 valence electrons.
16 to work with. Now let's put the carbon in the middle and the oxygens on the outside.
Okay, let's just go through and satisfy the octet for each of these elements.
See what happens.
All right, now let's count them up, see if we've accounted for all 16.
Okay, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20.
We've got
this
2 more than we
is
need.
not the correct structure because I only have
good.
16. I can't do 20. Okay. This is a little trickier, so we're going to give you another strategy here to use those 16. If you draw the individual dot diagrams, you'll see a clue as to how they bond. Okay? Because they want to be in pairs, right?
Yeah, so each of these electrons should be paired up with another electron.
So carbon, if you look at carbon, carbon needs to have 4 separate bonds because 4 of them are singles and they want to be together. If there's only 2 things to connect with, each carbon is going to have 2 bonds with the elements next to it instead of 1. So there's the 1, but carbon wants 2 bonds for this example. Okay? And then we can try and fill up the octet rule and go from there.
So we have to be careful because when there's 2 bonds there, that means there's 2 pairs of electrons that are attached to that oxygen there and the carbon next to it.
So really, I don't need electrons over here because now I've got 10 on the oxygen. Because the lines count, there's 4 of them in there. Okay?
Same thing for the oxygen on the other side. It's just the exact opposite, just other side.
So we can count, we've got 2, 4, 5, 6, 7, 8. So oxygen has 8. We leave this side blank because it has 2 bonds. The carbon also has 8 because it's sharing all 8 of them. And this oxygen has 8 as well. So 2, 4, 6, 8, 10, 12, 14, 16. That is the correct structure for CO2.